Hello. So this is actually the last presentation, I guess. Everything else is more like discussion. So usually in the last presentation you also do a kind of a wrap-up. Today, actually, I want to show you, for the ones who have been here last year, we have been presenting an idea and a concept about something that might be a project, that might be a program, that might be something that leads to a new, let's say, a new type of city. This year, we are already showing projects and we are already showing results, and hopefully next year we are already showing business effects and the impact that can be achieved by such thing. So eventually, what I wanted to show today is a little bit of criticism and why we started from a different perspective than maybe other projects, and why we think that this, what we started here in Ljubljana, has a long-term perspective. Well, this is, you know, my role at the institute, at the research institute, I have two roles at the research institute. First one is to take care about the strategy of how to transfer knowledge out of the institutes into real life. But the other part is that I'm also a researcher on the area of artificial intelligence. And I have also the fourth part, which is being a kind of an expert, external expert for evaluation of project proposals for the, let's say, European Commission, even from DARPA. And so I have quite a good overview about what is going on, what is there, and what are usual mistakes, and why these things are not kicking up. So usually when I see such kind of presentation about the future of the cities, new technologies, smart, whatever, intelligence, I ask simple question to those guys. So first is how to achieve this? How would you come from what we have right now to this picture? How far it is? So what do you think? And people are always say, well, you know, 100, 200, 300, 500,000 years. We don't know. The next question, are we really ready for it? Are we humans ready for such a thing? Because technology is ready there, and you don't believe that. So technology is already there, it's just that we are not using it because we might be not ready yet to use this technology in a way that is perceived in a such thing, which is a new type of city. Is technology there yet? Of course, for some things, for some not. So you will find a lot of very optimistic projects and a lot of very pessimistic projects in terms of technology. And the last question I always ask is, and since I'm the guy doing the artificial intelligence, I'm always asking, where the hell is smartest? Where is intelligence in this stuff you're doing? And more or less all the answers are a little bit not very specific. So we pose these questions out, and since we have here in Slovenia a team, and let's say that some very good world-level research teams, as the team I'm coming from the artificial intelligence lab, has right now around 50 to 60 researchers, depends on which period we are, which is the strongest group in Europe. And the things we are developing, also the stuff you will see in the next slides, are all real-life implementations in real complex, data-intensive, processing-intensive environments. So Slovenia has something to offer, and this was the first effect when we said, okay, so there is a need, we have something to offer, and there is something which is an environment that needs that. And so let's join forces together and do something like this. First thing which we usually miss with such projects, let's say, long-term project, is about pragmatic approach. Usually there's no pragmatic approach. When somebody will come to you and say, look, this is a greenfield investment, like for example, the Masdar city in Arab Emirates. I mean, this is now the thing which actually has problems because this is not a pragmatic approach. It's a large scale, it's a long term, but it's not pragmatic. And pragmatic means that whatever you do, it has to have some results, because then you are confident that you are doing the right thing. And this is something which actually creates an impact so that you can get others involved into it. So how are we able to understand what is there and use the resources we have to find a role, to find a goal? The next thing, wrong perception. Usually when you talk to the guys, they usually say, at least people are linear. We are not exponential, we are linear. We think usually, oh, when this will happen, okay, so if, the car was there in the beginning of the last century, so probably the next vehicle will be there in the beginning of the next century, because we think linear. It's not how the world looks like. It doesn't work like this. And it's particularly if you compare society and technology. Technology is raising much more faster than the society can expect and can reuse. And then smart, intelligent, cognitive. What is smartness? So usually what you see around when somebody is telling you that this is smart is that this thing has an algorithm, codified knowledge, and that means smartness. It's not much than that. When you combine those things together with something which is learning, which is looking at the real situation, extracting information from the illustration, putting that in a formal knowledge, then this thing becomes intelligence because it can adapt. It's not formalized knowledge which is strict in the algorithm, but it's something that actually adapts based on the real situation. And if you combine all those things together and make a loop, which is learning, memory, reasoning, and context generation, then you're doing the cognitive thing. So what we were telling last year was about we are building up something which is more than just smart. We are building something even that is more than just intelligent. We are looking at technologies that will actually make the thing cognitive. So why? Because everything what you see around the world and everything what you can model around the world is all about networks, is all about dependencies. There is one object, there is another object, and there is a dependency. And this goes for the universe, this goes for the neurons in the brain, this goes for the social networks, this goes for the knowledge networks, this goes for something which is semantic networks, is always the same stuff. It's not something very different. So what you do with this type of things is you collaborate. You put things together, you collaborate. Otherwise you are not making any progress. And of course, this means networking. And of course, this means sharing. And of course, this means symbiotic relations, because if you are sharing and if you are collaborating in the sense that I'm harming you and harming you, we will collaborate for just a few hours and then we will stop collaborating, right? So you don't do that. So whatever we develop and whatever we say we will put into this so-called smart city or intelligent city should be ready for being a part of a smart city. It should be ready to be networking, should be ready to share, and should be ready to behave in a symbiotic way. Otherwise, it doesn't work. Otherwise, it's dead. Pragmatic approach. What you do, or what we do, what we figure out is that you look what is there, you check what is there, so it is the infrastructure. Are there services already? Are there subsystems in the city already? And on the other sides, what we have on our disposal, the tools, the gadgets, whatever, you put those things together and you make something which immediately have an effect. So this is the case for the proposal, for the project you've seen yesterday, the presentation. It was yesterday, 2 presentations about the smart lighting, the stuff which is installed outside. Because this is one of the main building blocks we start with. There was a motivation to use smart lights and to put smart lights on top because there is an immediate effect, which is saving energy. But since you're doing that already, and if these lights are ready for the smart city, these lights are a little bit intelligent and can communicate, can share, can talk to each other and so on, then you are building something that is already a first building block for a smart city. And you have immediate effect. So, bottom-up approach, not top-down, because top-down means we will say, oh, this city, this Ljubljana city is very old, let's just wipe everything out and just build it again with completely new setup. It doesn't work like this, of course not. Step-by-step approach, starting from one part, going to another subsystem, first subsystem, fourth. We heard today about several things which are there already existing in a city. Those are the things you have to build on top of it. And immediate benefits. And we say, immediate benefit, at least investing from savings. Now, this is the strategy that has been presented several times ago already, so how we look at this, what we think about it. But the important thing is that when you look at these levels, you have this smart level, which is below, and you have the intelligent level, which is up, which goes in something which is a technology that looks a little bit far advanced, but it's not far advanced. There are already systems there that works in a cognitive way, as a cognitive systems. And if you put all the other subsystems below and start building this particular, very complicated, I don't want to explain that. It's just to see that this is quite complicated, it has several layers. You are approaching to something which is a new type of the environment. And if you have something like this, for example, at least for the lights, the first project we started and we are building without, so the scenarios you can put on simple street lights are many. It just depends on how many gadgets you will put on these lights, how many sensors, how many actuators, how these lights will communicate to each other. You can cover many different types of scenarios, and you can see everything from the traffic to advertising, even environment and so on. And the first level, which is the most important, is how to understand such a city. And understanding city means actually using such a type of network to collect all this data, to understand the data, to extract the information, to put this information in a formalized knowledge. That can be then used to do further reasoning. But what is more important is that how do you actually make the incentive for human? How do you make incentive for a citizen? Mayor on one other side, or the city on the other side. And you know, we have another mistake, we're usually doing another mistake, which is looking at ourselves. So myself, I'm old already. I see my kids at home, they're completely different. They're the ones looking at Facebook, how many likes they will get, because this is the most important thing when you go on Facebook, is you post the picture, you post the comment, and when you have many likes, then it means you have reward. Now, those kids understand what means reward. And if there is a simple counter in your house showing you the reward when you are saving energy, you are behaving completely different, because then you are aware of what you are doing. Then you understand the effect of what you do, which is in particular a problem for something which is a city or the country, because it is public money. And you say, oh, this is somebody else's money. Oh, it's not somebody else's money. It's your money. So it's just to be aware that whatever the mayor will do when he will install a new type of light, saving the energy actually affects your bucket. So this is, let's say, what we do. So we understand the data, we collect the data, we understand the data, and because we have the time dimension, we can also predict. We can also say, well, tomorrow it will be like this. So please, system, could you optimize the purchase for the tomorrow's time, energy, whatever, because we understand what will happen next day. Or, for example, we can use the same infrastructure to collect the data from other subsystems, like, for example, the water management, the wastewater management, the gas, whatever, which actually shows you, again, the monitoring, what is going on inside the city. Then is the next level. So when you collect the data, when you know what is going on, and when you are aware about your actions, then you interact with the system. Then you have these gadgets, whatever, you do whatever. So you do the microcontrolling around your house. You can program your interior energy efficiency management so that, for example, the fridge will go on in that time when the electricity will be the cheapest way. Or, for example, the stuff you have now, these intelligent devices which actually by themselves acquire and connect to the cheapest energy source. So this is something which is there already. It's just that you have to be aware that this have an effect. So personalization, microcontrol, and participation. So when we're talking about the intelligent city, it means that complete environment adapts to your needs, not to other needs, to your needs. Because it's a complex system, and if the system understands how you behave, what are your needs, preferences, then it can adapt. And this is intelligent. The other thing is just smart. This one is intelligent. And if you go further on, for example, this was the case which might be interesting for you. We did that. I have just a few slides and then I finished. This is, for example, the case we did for a few cities. So this one was understanding transportation inside the city, just based on the simple data we got from the simple sensors inside the city. But what can you do out of it? It's amazing. You can see, for example, which are the landmarks that attract more people in what time, in what particular segments. Or, for example, you can see how these landmarks are concentrating energy, or let's say communication, because here we used, that was Seoul in Korea. Since they don't have the limitation, they can get the data from your smartphones. So from the smartphones, you get all the data about all the people actually, how they move through the city and how the city actually breathes with the transportation. And when you know that, and when you know each particular goal of each particular person, you can of course predict in advance what will happen in a particular crossroad, whether there will be a traffic jam. And then of course you can ask the system, since the system is intelligent, you can ask the system, will I be late for my 14-hour talk? Or can I stop in between to take a coffee? Or should I drive, take a bus, take a bicycle? What's the best way to do? Because you know, you have this complex information. I have just my own limited context, which means I'm now here, and there is my goal. I want to reach this goal in this particular time. Should I take an umbrella? Should I take gloves? Or maybe an igloo? So I don't know what's the weather today. But the system knows what's the weather today because it has sensors. So this is something that actually leads to a comprehensive, I don't want to explain that at all. So those are the bits and pieces that are already put together as a software, as a platform to serve in several layers of the cognitive type of city. So I want to conclude with that, actually. I just wanted to show you why and how, let's say, Ljubljana and the resources of Ljubljana approach to this problem. I had a talk to the TV, whatever, the interview, and it came to my mind maybe a slogan for this project of ours, which we have to discuss. You know, we have this New York City, right? New York city that never sleeps. So since we are doing this symbiotic cognitive whatever city, we might say Ljubljana, city that always helps, which would actually show what we want to do. So let's conclude my presentation. Thank you very much.
Thank you.